Hello everyone, I'd like to welcome you to this video titled Squares and Cubes. And during this video you do need to get out your math book and turn to page 23, get out your math journal and a pencil. If you want to use a calculator, you can use a calculator as well. So let's go ahead and get those different supplies out. And you can see on page 23 the objectives or the goals for this lesson. There's three different ones. First of all, you want to find the square and cube of a whole number. And then also write the square and cube of a whole number using exponents, and also evaluate numerical expressions involving whole number exponents. So we'll take a look at those few things throughout this video, but those are the goals that you want to write down in your math journal. Now let's take a look first of all about finding the square of a whole number. Okay, so when we talk about finding the square of a whole number, what we know first of all is what is a square. A square has sides that are same length, same width, everything. Every side of a square is the same. So when we talk about finding the square of a number, more particularly the number 8 there, we can see that the square here has 8 centimeters, one length, and every length is going to be 8 centimeters. So in order to find the area of this square, we would just multiply 8 times 8. Or you can even write 8 to the power of 2. So 8 to the power of 2 would equal 64. A couple things within this. The number 2 in the 8 that we see right here is called the exponent. And then the number 8 is called the base of the expression. So we can see the square of a whole number is called a perfect square. You want to write that down. The square of a whole number is called a perfect square. So since 64 equals 8 times 8, 64 is what's called a perfect square. So we'll take a look at that throughout this video. Another example of this, we can see that 5 to the power of 2 equals 5 times 5. Therefore, 25 would be the perfect square. In other words, you multiply 5 by itself twice, and that'll give you 25. So let's turn our books to page 24, and we're going to do a couple problems together. You can work on these in the book with me. So we have finding the square of each number. So what we can see here is we have 6. In order to find the square, we do 6 times 6, and that would give us 36. Okay, so we can see that's how you find the square of 6. So just multiply 6 times 6, and that gives you 36. For number 2, we can even do it this way. 7 to the power of 2, that 2 is an exponent, which would equal 7 times 7. And 7 times 7 would give us 49. So we can see that 49 is a perfect square. Why is it a perfect square? Because when you multiply 7 times 7, that'll give you 49. Now, let's take a look at number 4 on this page. So we have 11. I know we're skipping around. That's okay. Let's write this out. 11 times 11 would give us 121. So that is the square of 11, 121. So we would say 121 is a perfect square. Why is that? Because a number could be multiplied by itself twice in order to get that number. Now let's take a look at number 7. So it says, given that 39 to the power of 2, or 39 times 39 is 1,521, find the square of 390. So you notice 390 is just a 0 added to the 39, and we're multiplying 390 by itself twice. Okay. So because of that, what we'll do is we multiply 390 by itself twice, and we can see a 0 is added to the 390. So all we need to do for that is just take that 1,521 and add 2 zeros to it. So we don't have to go through the whole entire process again or anything. So we just have 152,100 for the square of 390. Now let's move on down on page 24, and we're going to take a look at a cube of a whole number. So a cube has edges that are 4 centimeters long. Find its volume. So when we talk about the cube of a number, that means we're multiplying it by itself 3 times. So we can see that if we're trying to find the volume of this cube, we multiply 4 times 4 times 4. Okay, or we could say 4 to the power of 3. That's going to give us 64 there, as you can see on page 24. Now it says a cube of a whole number is called a perfect cube. Okay, why is it called a perfect cube? Because we can see that 64 is going to equal 4 being multiplied by itself 4 times. Therefore, 64 is a perfect cube. So not every number would be a perfect cube or a perfect square. It has to have the same number being multiplied by itself 2 times for a perfect square, and now 3 times for a perfect cube in order to be called a perfect cube. We can see 4 times 4 times 4 equals 64. Therefore, 64 is a perfect cube. Now let's take a look at page 25, and we'll take a look at some of these problems now. So it says find the cube of each number. So if we have 5 there, we're finding the cube of a number. That means we're just multiplying 5 times 5 times 5. And that's going to give me 125. Okay, so we could say 125 is a perfect cube. Why a perfect cube? Because you're multiplying 5 by itself 3 times. So let's take a look at number 5 there, 13. So finding 13, we can do 13 to the power of 3, or we can do 13 times 13 times 13. And that's going to give us 2,197. So you can say that 2,197 is a perfect cube because 13 multiplied by itself 3 times gives you that answer there. Now let's take a look at number 7, kind of like the other problem that we saw with squares, with squaring a number. Now we're taking a look at finding the cube of 21 to the power of 3. That's going to give me 9,261. All right, now all we did to that 21 is add a 0 to the end, which gives us 210. Should say just add a 0. We're multiplying it by 10. Therefore, we can add 3 zeros to the end of 9,261, and that will give us the answer to that problem. If we had 21 to the power of 5, okay, and we're looking at 210 to the power of 5, we would add 5 zeros. Why 5 zeros? Because it's to the power of 5. But since we're going to the power of 3, we're adding 3 zeros. So that would give us 9,000. So we can see, we write our number again, I should say, 9261. And then we can add 3 zeros to the end. So we have 9,261,000 there. Now the final part of the video we're going to take a look at is to evaluate numerical expressions that contain exponents. All right, and there's order of operations, and a lot of you know the order of operations can be looked at as PEMDAS. So we can see, please excuse my dear Aunt Sally there. Okay, so the P stands for parentheses, and then exponents, and then we have multiplication or division, whichever one comes in order from left to right. And I want you to write this down in your notes. Addition and subtraction, whichever one comes in order from left to right as well. So we follow PEMDAS. This is the order of operations. I always say the most important part of order of operations is the order of operations. So make sure you remember that. If you go out of order, you will get an incorrect answer. So let's take a look at the next page now, and we'll take a look at some of these problems here. So we can see number 2, for example. We'll do this together. I want you to write this down on a separate sheet of paper, and I'll write it out here. So we do 6 to the power of 3 plus 4 to the power of 2. Okay, so the first thing we do, parentheses, we don't have parentheses, now we do exponents. 6 to the power of 3, or 6 times 6 times 6 is 216. And then now we do 4 to the power of 2, that's going to give me 16. And then now after we add this together, 216 plus 16, that's going to give me 232 for my final answer. Now you can see that kind of makes like a slice of pizza there, okay? And the longer these problems go, the bigger slice of pizza you'll have there, okay? So that's how you do order of operations there. And let's take a look at number 7 there. So the first thing with these types of problems, you always want to write the number out. And I know I'm kind of writing over top of some work, but that's okay. So we write the problem out, 9 to the power of 3 minus 4 to the power of 2. Okay, sorry about that. So we write out our problem, 9 to the power of 3 minus 4 to the power of 2 times 3 to the power of 3. After we've done that, we can take a look at our different problems here. So we have 9 to the power of 3. We do exponents before anything. Since we don't have parentheses, we do exponents. 9 to the power of 3, 729. Minus 4 to the power of 2, that's going to give me 16. It's 4 times 4, 16. Times 3 to the power of 3. 3 times 3 times 3 is 27. Now the next step. So what we can see with the order of operations, just write it out here. We can see our next step is multiplication. So 16 times 27 is going to give me 432. And then we're just going to rewrite our 729 underneath that. And then the final step here, we can see we take that 729 and we subtract 432 from it. It's going to give you 297. You can see once again, it makes a nice big slice of pizza there. Who doesn't like pizza, especially during math? So 297 is the answer of that problem. So this concludes our video on squares and cubes. If you have any questions about this concept, please come and see me. I look forward to working with you on this concept in math tomorrow.